So the next conventional extraction technique is infusion. Now this technique is largely used to prepare dilute solutions or the extracts from the crude drugs. And in general, it has been found that if you are extracting a drug with the help of infusion process, then the infusions should always be prepared fresh before they are being used. So in this whole process, what we do is we take the desired amount of the drug and we macerate the drug for a short period of time with either with the cold solvent or with the boiling solvent. And in case of infusion, the solvent that is used is generally water. So we can say that we normally prepare aqueous extract or aqueous infusions of the drug, and therefore this process is largely used for the drugs which contain water soluble constituents. So for this process we take drug to solvent ratio in 1:8 or in 1:10 ratio, that is 1 gram of drug with 8 ml of the solvent or 1 gram of drug with the 10 ml of the solvent. So we allow the drug to stand with the desired solvent, whether it is cold or it is a warm or boiling solvent, for specified period of time, maybe 15 minutes or 30 minutes. This will cause the extraction of the soluble constituents with the help of the solvent, that is water, which we are using to extract. So the main point which has to be kept in mind is that we don't boil the drug with the solvent. We just take the boiling water, and to that boiling water we add the drug and cover the container with the help of suitable lid and allow that mixture to stand for say 30 minutes or 15 minutes, whatever the specified time period is there. Then we filter or decant the extract. So as I told you that these infusions should always be prepared fresh. So before you want to, if you want to use an infusion, so you should always prepare it in the fresh form. Now sometimes to increase the overall extraction efficiency, the crude drug is sometimes first moistened with the cold solvent, say for 10-15 minutes, and then that drug is exposed to the boiling water. This helps in increasing the overall extraction efficiency of this infusion process, because once you are treating the drug with, first you are moistening the drug with the solvent, it helps in the removal of the air, it helps in the swelling of the drug, because it will absorb the solvent, and once the drug is swelled, it helps in the formation of micro capillaries between the particles and within the particles, which allows the better penetration of the solvent when the drug is then treated with the boiling water. Next conventional technique is decoction. Again, decoction is also used to prepare used to extract the drugs that have water soluble constituents. Now, what is the difference between the decoction and infusion? Because infusion is also largely used to prepare is largely used for those drugs which contain water soluble constituent, and same is in case of decoction. In infusion, we just treated the drug with boiling water. We don't boil that mixture. But in case of decoction, what we do is we add the drug to the solvent, which is water in this case, and then we boil the mixture. Now this method is also used when you are using certain hard woody plant material or the fibrous woody plant material such as barks or roots are there, and as I told you, it is also used for those plant material which contain water soluble constituent. Now the drug to solvent ratio in case of decoction largely depends upon the type of the plant material that is being extracted. If you are using a softer drug part, say for example petals are there or leaves are there, then the drug to solvent ratio is less. That is 1 gram of drug can be extracted with 4 ml of the solvent. If moderately hard drug material is there, say for example barks are there, then we increase this ratio to 1:8. And if very hard material is there, say for example woody material or the heartwood of the plant you have to extract, then the volume of the solvent is further increased to 16. That is 1:16. Drug to solvent ratio of 1:16 is used during the decoction process. Now this decoction process is also used to prepare the Ayurvedic preparations which are known by the name of Quath. So what we do is we take the drug, we mix the drug with the solvent, desired volume of the solvent, and we boil the mixture at a low flame. Now this boiling first enhances the mass transfer rate. It also decreases the chances of formation of equilibration. It also enhances the solubilization of the constituent into the water. Further, we also boil the mixture in order to reduce the volume, and this volume is reduced to 1/4 of the starting volume if you are using the softer drug parts, and if you are using moderate or very hard drug material, then we reduce the volume to 1/8 of the initial volume. Once the desired volume is achieved after boiling after evaporating the water by boiling, then the resultant extract is cooled. It is then strained or filtered and is collected into the desirable or suitable vessels. Now the next conventional technique is percolation, and the word percolation has been derived from a Latin word percolare, that is to trickle through, because in this technique the solvent trickles through the drug matrix or the plant matrix in order to extract the desirable constituent. Now as you can see on the slide, there is a conical shaped extractor which we call it as percolator. Now in this the drug material is packed and the suitable volume of the solvent is added. Now if you add the dry drug material into the percolator and you add the solvent, so once the solvent comes in contact with the dried drug, certain amount of the solvent is absorbed by that dry drug and the drug swells in the percolator. So this swelling of the drug in the closed system sometimes causes or sometimes inhibit the formation of the channels between the drug particles, which will allow the passage of the solvent through that drug bed. Or air may get also entrapped because this is a closed system and you have added the dried material, and dried material contain large amount of air within the particles and between the particles. So if you add that solvent before moistening that solvent, moistening the drug material, the air will release from the dried material and this will entrap within the drug bed, and this will disturb the layer of the drug that has been set in the percolator, and this formation or this disturbance due to the air entrapment will cause incomplete extraction or non-uniform extraction of the drug material, because where the air is entrapped, solvent will not be able to pass through that area. So that area where air is entrapped, that drug material will remain partially extracted or will not be extracted by the solvent. And another problem while packing the dry material into the percolator is that the fine particles, because the dried material always contains certain fine particles, and these fine particles may wash down to the exit valve of the percolator and it may cause blockage of that valve, because these fine particles will wash down along with the solvent and they will get embedded or they will get aggregated towards the exit valve. So these are the few problems if you are packing a dry plant material into a percolator, and this problem can be overcome by a process which we call as imbibition. Now imbibition is nothing but pre-treating the drug material with the desired solvent which you are using it for the extraction. So we allow the drug material to stand in another container, say in a beaker or in a drum, with the desired or a suitable solvent for specified period of time. Now during this time period, the drug will absorb the specified amount of the solvent and it will swell. This will also help in removal of the air that is present between the particle and within the particle, and once the specified time period is over, that solvent is decanted and the wet material is then packed into a percolator in the form of layers. Now this packing is an important factor because it can be packed by applying small amount of pressure onto the drug layer, so that large amount of drug can be packed in the given size of percolator. But if that packing is very tight, you have applied large amount of pressure to pack that drug, then this tight packing also inhibits the free movement of the solvents through the drug material, and this also decreases the overall extraction efficiency of the process. So once that drug material is packed, a layer of a filtering aid, which is normally a clean sand, which is placed after placing a filter paper over the drug layer. We place a filter paper and then we add a layer of clean sand over the drug material. Now why this is added? Because when you will add the menstruum or the solvent into the percolator, this will not allow the solvent to disturb the drug layer. So that is why we add a filtering aid or a layer of filter paper over the drug material before adding the solvent. So there are few points one has to keep in mind while packing the drug into the percolator. The packing should always be uniform or even, and you can always make that layer uniform by adding a slight pressure, but mind you, you don't have to pack the drug very tightly because this will inhibit the overall flow of the solvent through the drug material. Then you can always add a layer of filter paper, which I have already discussed. You will add a layer of filter paper followed by a layer of clean sand, which will prevent the disturbance of the drug layer when you add the solvent. Now once you have packed the drug, we will now pour the menstruum or the solvent into the percolator. Now while pouring that solvent, one has to keep the exit tap of the percolator always open, because during imbibition the air that was entrapped between the particles and within the particle was removed. But once you shift that wetted drug into the percolator, large amount of air then also get entrapped within the particles, not between the particles, not within the particles. So when you will add menstruum into the percolator after packing the drug, that air will find a space to release or to exit that particular container, and that can be done by opening the exit tap of the percolator. So air will exit the percolator from the exit tap. Now you have to keep this tap open till the menstruum flows out. Now if we don't keep this tap open or we close this tap, then the air that is entrapped will have to escape the percolator through the upper layer of the drug, and this will disturb the overall packing of the drug that has been put into the percolator, and this will cause partial extraction or incomplete extraction of the drug. So therefore, once the drug is packed and you have to pour the menstruum into the percolator, you open the exit tap till the menstruum flows out from the exit tap. Once the menstruum starts flowing out of the exit tap, you close the tap, cover the percolator and allow the mixture to stand for 24 hours. And after we open that exit tap, we collect the extract, and with a continuous with a specified rate, we add the more volume of the fresh solvent onto the percolator, and this process continues. Now certain modifications have been done in the percolation method as well, and for the thermolabile constituents if the extractions are done in hydroalcoholic mixtures. So reserved percolation is one modification, and second is the cover and run down method. In reserved percolation, we perform the normal percolation process by packing the drug in a percolator and extracting with the suitable solvent. Once this extraction is complete, we concentrate the extract to remove the large amount of water that is present in the extract, and then the remaining reserved amount of the solvent is used to solubilize that extract. So this is reserved percolation. Second is cover and run down method, and in this what we do is we allow the drug to percolate first by maceration, because we pack the drug, we add the solvent, we allow this mixture to stand for specified period of time, which is nothing but maceration, and then we open the exit tap to calculate the extract. Now once we open the exit tap, we will again add the fresh solvent from the tap, and it is allowed to wash the drug material which comes out through the open exit tab. So this is cover and rundown. For the initial part, we expose the drug towards maceration. Once maceration is complete, we then percolate the drug material with the suitable solvent. Now, depending upon the temperature at which extraction is being carried out by percolation, this can be a hot percolation, wherein we use a warm solvent, not boiling solvent but warm solvent, and it can be a cold percolation wherein the solvent at room temperature is used. Now this is a picture of an official continuous extractor. Here the drug is again extracted with the percolation procedure, and this method has been used as an official method in case of Indian pharmacopoeia and British pharmacopoeia. So as you can see, this is a simple extractor that is attached to a conical flask which contains the solvent, and in the extractor there is a small tube like structure which contains the drug material, and this tube like structure we call it as thimble. So what happens is we pack the drug in the thimble and place this thimble in the extractor, and this extractor is attached with a condenser on the top. So we heat the conical flask which contains the solvent evaporates and they pass through the opening of the extractor. The vapors move towards the condenser, they condense, and the solvent then falls dropwise into the thimble which contains the drug. So again the drug will trickle down into the conical flask. So this is a continuous process. Solvent again boils, vapors rise into the condenser, they get condensed, and the solvent falls down onto the drug. Now the main point that has to be noted in this, every time the drug is extracted with the fresh solvent, because the solvent vapors are evaporated, leaving behind the solubilized material into the conical flask, and these solvent vapors are condensed, fresh solvent fall on the drug that extracts the drug material that is present in the thimble. So that is why it is known as the continuous extractor, and the major advantage of this method is the solvent does not get saturated for whatever time you are extracting the drug material, because every time the fresh solvent is falling on the drug. So this increases the overall extraction efficiency of this process. But the major disadvantage is you cannot use this method for the thermolabile constituents or the drug that contain thermolabile constituents, and this method can also not be used when you are using a ordinary binary mixture of a solvent, because you will be heating the solvent. So the solvent which will be having a lower boiling point will get evaporated before the solvent having the higher boiling point, and the extraction will be done by a non-uniform mixture of a solvent. Now we move on to an important conventional extraction technique that is widely accepted and is still being used at a very large scale, and this is the soxalate extraction. Now this extraction technique is also known as a hot continuous extraction, because again the solvent is evaporated and is condensed with the help of a condenser, and this cycle continues. Now this extractor or the soxalate extractor or apparatus was designed by Franz von Soxalate in 1879. You can see the image of a soxalate extractor, and in the image you can see there is a round bottom flask which contains the solvent. This round bottom flask is attached to the soxalate extractor, which is further attached to the condenser. Now this soxalate extractor has three major parts. On the left side you will see a thin U-shaped bend tube which we call it as siphon tube, and on the right side you will see a handle shaped tube which we call it as a vapor duct, and between these two tubings there is a cylindrical area which we call it as the extraction chamber. Now this extraction chamber we place a thimble which is made up of say fine filter paper, and we place this thimble into the extraction chamber and the drug is added into the thimble. Now if you carefully look into the diagram, you will see that siphon tube which is on the left side of the extractor, this siphon tube is attached at the bottom of the extraction chamber, and then it moves upwards, have a U bend, and after bending it comes back into the round bottom flask. So the addition of thimble into the extraction chamber is just to prevent the blockage of the siphon tube from the drug particles, because if you add drug material as such into the extraction chamber, it will enter into the siphon tube and it will block the siphon tube and the whole extraction process will stop. So what happens in the soxalate extraction is, we boil the solvent in the round bottom flask. The vapors from the vapor duct on the right side, they will move towards the condenser and they get condensed. The condensed droplets of the solvent, they fall onto the thimble where drug is packed and they will extract the drug. Now the level of the solvent will rise till the bend of the siphon tube. So once the solvent reaches to a height where the bend of the siphon tube is present, it will trickle down back into the RBF. So again, then RBF solvent is boiling, the vapors will continuously move towards the vapor duct, then to condenser, they condense there, fall onto the thimble, onto the drug. Again the level of the solvent rises till it reaches the height of the siphon bend, and again the solvent will trickle down back to the RBF. So the continuous cycle will go on, and that is why it is known as hot continuous extraction method. Now there are various advantages of the hot continuous extraction method or the soxalate method. So as you have seen that this soxalate apparatus is a closed system, so very less amount of solvent is required in comparison to maceration, in comparison to infusion or decoction, because every time the solvent is keep on recirculating in the extraction process, and that solvent gets condensed and drug is extracted every time with a fresh solvent. Therefore the solvent never gets saturated with the phytoconstituent, and this unsaturation or this inhibition of the saturation increases the overall extraction yield. And if you have seen the diagram carefully, then you must have observed that the extract and the drug always remain separate. The extract is present in the round bottom flask and the drug that has to be extracted is always present in the extraction chamber. So there is no contact of the drug and the solvent or the extract. Then this type of extraction procedure is already accepted by various regulatory agencies, and different sizes of soxalates are available in the market. You can see one of the industrial scale soxalate apparatus in the picture, and even in the laboratory level you can find the soxalate having a volume size of 50 ml to say 5 liters or 10 liters of the volume. So different sizes of soxalates are available. So depending upon the amount of the drug you want to extract, you can select the size of the soxalate. It also has certain disadvantages, as we have discussed that solvent has to be boiled, which is present in the round bottom flask. So this method cannot be used for the thermolabile constituent or the thermosensitive constituent. It can be only used for those drugs which have thermostable constituents. This process we have to continuously boil the solvent, therefore it is an energy consuming process, and it can only be used for pure solvents or azeotropes. Again, it cannot be used for the binary mixture, ordinary binary mixture, because this will cause non-uniform, I will say non-uniform mixture of the solvent which gets condensed, because the solvent with lower boiling point will evaporate in larger amount in comparison to the solvent which is having a higher boiling point. So drug will not be extracted by the ratio of the solvent that was selected for extracting that drug. So these are few disadvantages. One always have to take certain precautions while using the soxalate extraction procedure. First and the foremost is you always have to take care to prevent the blocking or clogging of the siphon tube, and that is why I told you that we normally prepare a thimble of filter paper to pack the drug into the extraction chamber. So if you don't want to make a thimble of filter paper, you can place a cotton plug at the base of the extractor, as you can see in the picture on the left. Here we have added a cotton bed at the base of the extractor. Then the drug is packed. Then the level of the drug. One has to be very careful while packing the extractor. The level of the drug should be below the siphon bend that is present on the left side of the extractor. Why? Because as soon as the level of the solvent reaches to the bend, immediately the solvent will trickle down from the siphon tube back into the RBF. So if you have packed the drug at a level which is above the bend of the siphon tube, then that amount of the drug which is present above the bend of the siphon tube will not be extracted properly, because that area will not come into the direct contact of the solvent, because every time the solvent will reaches up to the bend of the siphon tube, it will trickle down back into the RBF, and the drug placing above that siphon bend will not be extracted properly. Then the level of the thimble is also important. If you are using a thimble, the level of the thimble should be such that it should not block the vapor duct which is present on the right side of the soxalate extractor, because if thimble occludes or blocks the opening of the vapor duct, very less amount of vapors will enter towards the condenser, and the overall volume or the extraction time will increase. The volume of the solvent, one has to be always careful while using the volume of the solvent. You have to very carefully select the volume of the solvent, because if you are using large amount of the solvent, then the process will become uneconomical. If you are using less amount of the solvent, then what will happen is the solvent is continuously boiling, it is getting condensed, and it is entering into the extraction chamber. So if you have not added sufficient amount of solvent into the RBF, and whole of the solvent has been evaporated, and the solvent does not reaches the bend of the siphon tube, the extract that is present in the RBF will get charred. So normally what we do is we take roughly 2 volumes of the siphon in the RBF. So we add the solvent into the extractor, the solvent reaches to the bend of the siphon tube, and it trickles down into the RBF. We again add the solvent into the extraction chamber, again it reaches to the height of siphon bend, and it trickles down into the RBF. So this is the 2 volume siphon volumes of the extractor, because when the solvent will boil, only 1 volume of siphon volume will enter into the extractor and 1 will remain in the RBF, and this will prevent the charring of your extract. Then we should always use the azeotropic mixtures or the homogeneous mixture. We should not go for the ordinary binary solvents while using the soxalate extraction. Now there are certain modification of the soxalate extractors. One such modification is an integrated system, and this integrated system has 3 type of extractor. One is soxalate extractor, then second is the classical hot or the Randall's extraction, and the third one is the hot continuous or Twisselman method. So as you can see in the image A shows the normal soxalate extraction, image B shows the Randall's extraction or the classical hot extraction, wherein the thimble of the drug is dipped in the drug, and the solvent is boiled, the vapors get condensed, and they again fall onto the drug. And the Twisselman method is nothing. You can just imagine a continuous hot extraction, classical continuous hot extraction method, wherein solvent is kept in an RBF, and the vapors, they get condensed and fall onto the drug that is present in the thimble. So all these 3 techniques have been integrated into a single I will say equipment, which is nothing but a universal extractor that is produced by Bucchi from Switzerland, and this type of extractor is largely used to extract the drug by these 3 different techniques. You can always study, you can always compare the extraction efficiencies of these 3 methods. You can always extract large amount of a drug in this fully automated system. So friends, this was about the soxalate extraction, decoction, infusion, maceration and percolation. In the next lecture, we will further discuss about certain modifications of soxalate extraction. Vis-a-vis, we will also start with certain modern extraction technique in the next lecture. Thank you.